All right, this is part 2 of our lesson about rational expressions, equations, etc. This is a review for a test on this unit, so use it for that purpose. All right, for number 13, we're supposed to find the least common multiple, and that's going to be pretty easy to do since these are prime numbers anyway. So basically, on the left here, we have the 3, and we have x squared, and we have y to the 6th power. Okay, and on the right, we have 5 and x to the 3rd power and y squared. So we need to make these both be the same, and we can only give new factors. We can't take any factors away. We can multiply, but we can't divide or anything like that. We can't cancel anything out. So this side has a 3. The purple side does not have a 3, so we have to give it a factor of 3. All right, the purple side has a factor of 5, so we have to give the blue side a factor of 5. Now, remember, these x's have to be the same, but I can only give more, I can't take away. So this has 3 x's, so I'm going to have to bump this up to 3 x's as well. Okay, now the blue side has 6 y's. This only has 2, so I can only give more, so I'm going to bump this up to 6 y's. All right, now they are both the same, therefore this will be the least common multiple. 3 times 5, of course, is 15. And then I will have x to the 3rd power, y to the 6th power. All right, let's see if number 14 is any more challenging. All right, number 14 has factoring and such. So let's check it out. This will factor as x and x, 2 and 1, positive and negative. And on the purple side, this will factor as x and x. Let's see, probably 1 times 6. No, obviously that's not going to work. 2 times 3 is what I mean to say. And that's going to need to be positive and negative. All right, so there we factored that down. And now, they all have to be the same though. So on the blue side, I see an x plus 2. Purple side has 1. Okay, on the blue side I have an x minus 1. The purple side does not have 1. So I'm going to have to give the purple side an x minus 1. Okay, now the purple side, in addition to the x plus 2, it has an x minus 3. So I'm going to have to give the blue side x minus 3. Okay? Now they all have x minus 1, x plus 2, and x minus 3. X minus 1, x plus 2, x minus 3. Now they're all the same. So that means we are looking at the least common multiple, which is x plus 2, x minus 1, x minus 3. The order of these factors does not matter. All right, so number 15, we got add, subtract, identify any excluded values. By the way, the test is real specific. If I don't specifically say something about writing excluded values, don't worry about it. I mean, if you put excluded values and I didn't ask you for excluded values, I don't care. I mean, you're not going to lose any points or anything, but you don't have to worry about it unless I specifically say. But on these problems, it does say, identify any x values for which the expression is undefined. So we will have to do excluded values on number 15. When you're adding and subtracting, you need like denominators. Well, this one's extra easy because the denominators are already alike. So we can go ahead and just put these together over the common denominator of x plus 4. And I'm just going to combine like terms now. So that's going to be 6x minus 8. Okay? In my mind, I see the GCF there in the top. I'm imagining if I pull out that GCF of 2, is there going to be anything I can cancel out?
Maybe.
No, so I really can just stop here and let this be the answer. If I pull out that 2, that's fine as well, doesn't matter. Excluded values though. X cannot equal -4, and that's it. Any questions on number 15?
Oh, this is easy now, Mr. Bernie.
Well, the denominators were the same, so you know. Now, please be careful on number 16. I'm emphasizing because you see that negative sign in the middle. That's the type of thing that you guys mess up on a lot. Okay? You have to make sure that that negative sign winds up distributing properly. Okay? So, the thing is, we already have like denominators. Okay? So just out of an abundance of caution, let me show an extra step that I normally wouldn't do. Okay? I'm putting these numerators together, but looky here. Okay? This is like, I've encouraged you, when you see a subtraction problem, to think of it as plus, negative. Okay? But please understand that negative sign has to get distributed across the binomial. It's not just going to be a -3. It's going to affect the 2 as well. So it should be, and I'm just going to show this step that I normally don't show. So it's going to be 12, and it would be -3x plus 2, not -2. That's the most common error right there. And then you go on with the problem. So this would be -2x plus 14 over 2x minus 5. Okay? Now, I see the GCF in the numerator. Is this one where I have to factor it out? No, because if I factor it out, nothing will cancel anyway. Can I cancel out anything that's here now, like maybe the x's or the 2's? Can I cancel any of that out?
No.
No, because it's connected by addition. So this is the answer. Okay, the excluded value is x cannot be what now?
5/2.
5/2. Okay, just in case there's anybody that's like, what? Where did that come from? We're looking at the denominator, and the denominator cannot equal 0. So we're solving this out. 2x cannot equal 5, divide by 2. X cannot equal 5/2. Any questions on number 16? Go. All right, number 17 is going to have to be factored down a bit. So this is going to factor down as I heard.
X minus 4, x plus 3.
X plus 3.
X minus 4, x plus 3. Okay, very good, very good. But we need like denominators though. So you know what, I'm going to just recopy this. So right now we have x plus 4 over x minus 4, x plus 3. And then over here we have plus,
2x.
and we got this 2x over x minus 4.
Don't you just
Okay?
have x plus 3?
We need the denominators to be the same, so
Now you move the x plus 3 to the other side.
correct. They both, I hear you saying that they share an x minus 4 as it is. So that's great. But if only this side had an x plus 3, then they'd be the same.
Don't you
Do
have
the same
that?
thing for the top.
Don't I have to do the same thing in the top?
That's true.
Okay, so I put the x plus 3. Usually at this point, somebody pipes in and says, Mr. Burton, shouldn't you cancel out those x plus 3's? And I have to explain that I just put those there. So no, don't cancel them out. So now that we have like denominators, we can go ahead and use the like denominator. X minus 4 times x plus 3. And don't have to worry, there's no minus sign I have to stress about. But if there is, man, I hope you guys really focus on it. I'm going to distribute this, so that'll make 2x squared plus 6x. Okay? So I'm just going to rearrange that properly a little bit. Thank you. Very good. Excellent. That's so funny. Minus 4, x plus 3. Okay, so I'm going to pause the video for a second, as the class and I analyze whether or not this is factorable. That was quick. I guess I'm not pausing the video. Okay. It's not. We're not going to analyze any further. The consensus is that it's not factorable. Therefore, this is the answer.
Isn't most of the time?
Then we got time for that.
factors,
I don't know most. I don't know from most of the time. Just I take it each case separately. And then the restrictions: x cannot equal 4 because of that. X cannot equal -3 because of that. And that's all there is to that.
It is. I don't know.
Aw shucks, a negative sign. Better watch out. Focus. Okay, so anyway, we got to factor and stuff. So this is going to factor down. I might as well just do it down here, whatever. So this is going to be, I heard x minus 6, x plus 3. Okay, that sounds right to me. All right, nothing happening up there, so I'll just have to keep that what it is. 3x squared minus 1. Okay, I'm keeping such a close eye on that minus sign. I don't like it. It doesn't like me. We're not friends.
So don't put any problems on the test.
I don't write the test, brother. I'm the video guy.
Mr. I have a question.
Oh Lord, Abdullah alert. Okay, so they both share the x minus 6's. So this side just needs the x plus 3. So I'll give it the x plus 3 on both sides. Okay? Now the denominators are the same. That's great. I probably would go ahead and FOIL or double distribute this binomial right here. Get that out of the way. It'll make it easier to distribute later. So I'm going to do that off to the side. Okay, so we got the x plus 2 and we got the x plus 3. I'm just going to do it, man. Gosh. Okay, so if I do x times x, and so I got x squared and 3x, and then 2x,
Plus 6.
and then 6 plus 6. So this is going to make x squared plus 5x plus 6. So that's what this is. So I hope you don't mind if I just go on and erase it and replace it. See, sometimes I accidentally rhyme. It's part of my awesomeness. Erase it and replace it, y'all. What's up, Chaslin girl?
Mr. Bird.
The main thing is to make sure this minus sign gets distributed across this trinomial, okay? And what I normally like to do, I'm going to change colors for just 1 second. I would like to put parentheses around this, and I will go plus negative, okay? Just to make it real obvious, I'm going to take this minus sign and distribute that thing, okay? So when I go ahead and combine this into one fraction, my common denominator, I'm going to copy it, okay? But then I'm going to have 3x squared minus 1. Okay, now here comes this with the distribution having happened. Don't judge me. So that's going to be negative. Mr. Burton can't talk. He's black. X squared minus 5x minus 6. Okay? So please, 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 a common, all too common mistake is that kids don't distribute the minus sign and they just put minus x squared plus 5x plus 6. And then, of course, the whole problem's wrong.
Yes, sir.
All right, so we'll continue from there, combining these like tisms. Let's see. So 3x squared minus x squared, so that's 2x squared. Okay, and then we have the negative 5x. And then we have negative 1 and negative 6, so that's negative 7. And then we have the x minus 6 and the x plus 3. All right, is this factorable, class? Okay. I'm told no, it's not factorable.
No one's factor?
No.
Okay? And even if it was factorable, nothing would cancel. I can see by the 7 it would have to be 7 and 1, and that wouldn't cancel anything anyway. So either way, it doesn't matter. So that's the answer. The restricted values. X cannot be 6 because of that. X cannot be -3. Oh man, my 3s are bad. Whatever, I'm leaving it. X cannot be -3 because of that. Any questions on number... Oh, did I slid over to the other problem. Any questions on number 18?
Oh my.
Okay, so yeah, it turns out it does factor, actually. Upon further consideration, we've reviewed the play, and it does factor 2x minus 7, x plus 1. Either form is acceptable. Either form, because nothing canceled, either form would be acceptable. If something did cancel, then you had to have factored and canceled. Okay? Wait, hold on. All right, number 19. Same type of thing. So here we go. We got x plus 2 over, okay, 3 and 5 plus minus. Okay, over here, I've got x and I've got x plus 3. So here again, they already have something in common, x plus 3. But they need to have x minus 5 in common as well. So I'm going to do that. Okay? This one should be relatively easy because there's no negative sign I have to worry about distributing. So this is going to give me x plus 3 times x minus 5. And I've got my x plus 2. And then I'm distributing this. So that's going to give me plus x squared minus 5x. So that's going to give us x squared minus 4x plus 2. And that's definitely not going to factor. Okay, so that's it for number 19. Except for the excluded values, of course. We got x cannot equal -3, and x cannot equal +5. All right, number 20. See that negative sign? Watch out for the negative sign. Make sure it does what it needs to do. So I'm going to have x plus 6. I'm going to factor this. This is going to be x and x. 2 times 9, positive, negative. Okay, and over here I got my 2x, and I have my x minus 9. Okay, what do you think I'm going to do right now in the denominator?
Up there.
All right, the left side has an x plus 2, so the right side is going to need an x plus 2.
Will we have graphing calculators?
You'll have access to a graphing calculator, yes. Okay, so we got this. And now's what I'm going to do. Let's look at this subtraction as plus a negative. So then we don't have to worry about it anymore. Just make it a negative 2x and it's all good. Okay, so when we do it, so we will have x plus 2 times x minus 9. And I have my x plus 6. And I'm distributing a negative 2x. Not just 2x, negative 2x. So that's going to make, and you write right next to the microphone too. So that's going to give me negative 2x squared minus 4x. Okay? Right there would be the most common mistake. If this were a test problem, so many kids would leave that positive. But hopefully the way I've emphasized it, at this point, that won't happen anymore. It still will? I'm afraid it will too. Especially the way some of y'all sleep and stuff sometimes. So that's going to be negative 2x squared, negative 3x, plus 6. Okay?
I'm going to screen.
Now, if we were going to try to factor this, the first thing we would do is pull out that negative sign. So that would leave negative 2x squared plus 3x minus 6. Okay? And that's the thing we would look at and to try to now factor. All right. So I talked to my counsel about it, and we agreed that this is not actually factorable. So we might as well just have left it as the previous step. So I'm just going to erase this. But it's you need to. What's up with the noises, people? The two people closest to the microphone making all these sound effects.
We're trying to be popular,
Okay. All right. So that was number 20. Almost forgot the excluded values, which are x cannot equal negative 2, x cannot equal positive 9. All right, so this one, we're changing to a different kind of problem. Now we're solving these equations. So it's no longer about like denominators. For these, it's about multiplying through and canceling out all the denominators. All right, what do you think I'm going to multiply through by? R plus 2. All right, so I'm going to multiply by r plus 2 everywhere. R plus 2, r plus 2, r plus 2. Okay? So what happens is the r plus 2's cancel out. All denominators should end up canceling out. So these cancel out. These r plus 2's cancel out. Okay, so that's going to leave us with 12r is equal to 4. And again, one more time, you see that negative, right? You have to treat this like a negative 6. So yes, I'm going to distribute, but I'm not going to have a positive 12. Okay? I'm distributing a negative 6.
Negative R.
And this is going to make negative 6r
Negative 12.
minus 12. Okay, that is the most common mistake right there. More than half the class would tend to leave this as a positive 12. You've got to stop doing that. Okay? So then we just keep going. So I have 12r is equal to negative 6r minus 8.
So negative 18R.
I would add 6r to both sides. Okay, so that's going to give me 18r is equal to negative 8. Then I would divide both sides by 18.
I made a big mistake right now.
My friend.
I have a question. You finish the problem I asked.
Okay, so that's going to give me r is equal to negative 4 ninths.
Ugly ass.
Mr. Brown, can I ask a question?
Okay, and we have to make sure that this is not an excluded value. Okay, so let's just look back up and see. All right, well the only excluded values are that r cannot equal negative 2. All right, so that solution is fine. So number 22, this would be a good one to just simply cross multiply. When you have a fraction equal to a fraction, I could multiply through by x minus 4. Actually, that would be so easy. I kind of want to do that now that I mention it. So I'll say normally I would cross multiply, and I would go 4x times x minus 4 is equal to, 2x plus 8 times x minus 4. That's what I would normally do. And you could do this and it would turn out fine. But because both denominators are actually the same, look how easy it is if I simply multiply through by that denominator. Right? If I multiply both sides by x minus 4, then these x minus 4's cancel out immediately. Gone and gone. Gone and gone. Okay, so that's just going to leave me with 4x equals 2x plus 8. Okay, subtract the 2x. And then 2x equals 8.
Divide by
Divide by
2.
2.
X equals 8
X equals 8 over
over 2.
2.
And then 4 over 1. Wait, no. Yeah. Yeah. 4 over 1, right?
Well, can we just say 4?
4. Yeah.
Like, you know what I mean? 8 divided by 2 is 4. Let's just go with that route.
Yeah.
Okay? But what happens when we go to state the restrictions? Oh, snap.
X can't equal. Oh, X can't equal 4, so there's no solution.
Oh, x can't equal 4. Right? That's our excluded value. So x can't be 4, so we have to throw out our only solution. So that's why the answer is no solution. Okay, no solution on number 22. So always watch out for that. All right, I'm going to go ahead and stop this video here. We'll be picking up with part 3 on the next video. Lots more to come.